Hello everyone. In this video we're going to use Excel to help us out answering some discrete random variable problems. Okay, so let's look at this first one. So here we have that Pam is looking to invest some of her hard-earned money. She has found a classic investment that she knows is pretty safe, but a friend showed her a startup that possibly has a huge return. The following provides the probabilities of returns for respective investments, help Pam determine where to put her money. Okay, so this is a classic example of where we are given the support and the probability, and then we need to calculate out the other things. So in other ones, like where we have uniform or binomial, there are some rules that we can use to determine what the probabilities are, but this one is just generic, and so we have to be given it. So let's go ahead and label up our first column as the classic example, so we'll just classic. And we're going to label up our three columns first as X, PMF for our probability mass function, and CDF as our cumulative distribution function. Okay, so X, remember, members of the support, it's all possible outcomes of this investment. So we could walk away with losing $2,000 from our investment. Another option is we could make $3,000 or we could make $7,000. And the PMF is the probability for these to happen. So the first one is 3 divided by 10. The second one is equal to 1 divided by 2. And the third one is equal to 1 divided by 5. Now, if we add these up, 0.3, 0.5, 0.2, they should add up to 1. And the CDF, how we're going to do this, is we're going to say equals, and this first one just equals the PMF. And this next one, we can just do equals the sum of the PMF that we're on, comma, the one that is above us in the CDF, or summing everything above. So we can do that, and if we drag it down, then we add up to 1. And you know you've done it right if your CDF equals 1. Okay, great. So we have our PMF, we have our CDF, and we have our support. Okay, the next thing that we need to do is we have a set of questions of what are we going to see from this classic investment? Okay, so in order to do this, we need to do a couple of calculations here. So the first thing that we need to do is we need to do the support, the specific member of the support, multiplied by the specific member of the PMF, or when big X equals little x. All right, so to do this, we can do this really quickly in Excel. We can just hit equals, and I'm going to take specific member of the support multiplied by the PMF. And if we hit enter, we get negative 600 for this column, and we can drag those guys down. Okay, so for any discrete random variable, we can do this column, and we can say that the expected value, or if we were to do this investment over and over and over and over and over again, on average, how much money would each of these times that we invest be? And that would just be equal to the sum of, let's try that again. It's the sum of this column right here. And so we have that our expected value is going to be $2,300 from this investment. Okay. So we have that for our classic example, and we can put that in for our expected as 2,300. And then this next question is, what return are you most likely to see from the classic investment? Okay, so all that's asking is just look at the PMF. Which member of the support has the highest probability of occurring? And it's $3,000. It's the highest one that we can see. Okay, and then we have what's the expected value of the startup? Okay, so now we need to figure out what's the expected value of the startup. So in order to do the startup, we're going to do this exact same thing, but all we have to do is just change out some values. So we'll do the startup. And we could go through and type all this out again and redo these equations. I'm going to cheat. I'm just going to highlight all of this. I'm going to copy it. And then I'm going to come over under the startup, and I'm just going to paste it in. Okay, then from here, I'm just going to delete out my support and my PMF because those are different. Notice how these updated. They are equations, so they're continually updating. So on the startup, I could possibly lose $11,000. I could possibly lose $6,000, but I could also walk away with $42,000. So the startup here, 3 divided by 5, equals 3 divided by 5. Make sure you have that equal sign. And then I could put in equals 1 divided by 3, and then equals 1 divided by 15. And now I have all of those, and we can do the expected value of x, or the expected value of the startup here, is going to be equal to the sum of those ones right there, and I have negative 5,800. Negative 5,800. So on those, the investment that you are most likely to lose money is going to be with the classic, or with the, sorry, not the classic, the startup. Okay, suppose we have invested in the startup scenario, and your account manager told that you have lost money. What is the probability that you have only lost $6,000? Okay, so in order to do this one, this is a given statement. Probability that we have lost money, or sorry, probability that we have that the random event is equal to negative 6,000, given that we have lost money. Okay, so if we look at this, we say that, hey, these are the events where I have lost money. So this is my new sample space. And let me highlight in green, or maybe instead of highlighting, let's put a border around this one. We'll put a thick border. And I want to know what's the probability that I am at 6,000. Okay, so in order to do that, I'm going to write this in a new format. I can do the probability that we have, we'll do x equals negative 6,000 intersect lost money. And we can now divide that by the probability of lost money. Okay, so the intersection, let's get that out. Probability x equals negative 6,000 intersect lost money. Okay, is going to be equal to, where do these two events cross each other? It's just at negative 6,000, and the probability of that is going to be equal to this one. Okay, and then that the probability of lost money is just going to be equal to the sum of these two members of the PMF. So I could either grab it like this, or I could have just grabbed it from the CDF. Could have done it like that. And so up here, now I can do that this is going to be equal to the intersection divided by probability of losing money. Hit enter, and I have there's a 35% chance, roughly 0.37514, that we have lost $6,000. Okay, suppose we have invested in the classic scenario. What's the probability of not losing money? Okay, so if we're in the classic scenario, probability of not losing money is going to be the sum of everything that isn't losing money. So we could just equal the sum of these two guys right here. Probability of making 3,000 and the probability of making 7,000, not losing money. So we have a 70% chance of not losing money. So that's how we were able to do that. Let's just double check and see how we did. Yep, and we were able to knock all of those out. And that's how we can use our classic probability and the probability tables for the classic example and the probability tables for the startup example to answer these two. Now there is one more thing that we can look at to see the variance, because sometimes we're asked questions on the variance. So let's go, and I'm just going to remind you guys that there are very handy cheat sheets that we can be using. So we can go into like the statistician's toolbox, go look at the discrete random variable cheat sheets. Let's just grab that and let's open it up real quick. Okay, here we go. Let's enable editing. Okay, so this sheet is really handy because it tells you, like, this is a quick reference on how to build these probability tables. The nice things too is that there's actually equations in here, so you can see exactly what I did in order to calculate those. Now, if you look at this is the one more thing that we want to do, is calculating out the variance. And the way that we do this is we take the members of the support minus the expected value, square it, and multiply it by the probability of the event occurring. So let's do that on ours real quick too, so that we can just see how we would get our variance. Because sometimes it's another piece of information that we want to include. So here we can do x minus mu squared multiplied by the probability of x equaling little x. All right, so when we write it up like this, it makes it handy because then we can just grab out pieces from here. And the expected value is equal to, it's the same thing as saying equal to mu. Okay, so here is what we can do. Let's just double check our equations real quick. Make sure that we got it right. X minus mu squared times the probability of the specific event happening. And then what we're going to do is just like in the expected value one, we're also going to sum it up to get our variance, and then we can get our standard deviation by taking the square root. All right, so let's hide that. And let's start off with an equal sign so that we can actually do our equation. So it's going to be parentheses, our specific event, multiplied by the, give me a second, oh, not multiplied, minus our expected value. Now, one thing that I'm going to do a little trick here where I'm going to push the button on our keyboard called F4. So if you have the function kind of line at the very top of your keyboard that says all the functions, F4 does this little thing. It's a shortcut to put $ by the letter and the number. And what that does is it's going to lock the reference of the column D and the row 8 so that this number won't move, because I'm going to drag this down so I don't have to type this equation out over and over. All right, so I have that. I'm going to raise it to the power of 2. I'm going to multiply it by its specific probability of success. I'm going to hit enter. I get this huge number. Don't worry about it. The variance can be very, very large. And then I'm going to drag it all the way down. And if we click on it, we can see it said, hey, these references dropped down, but this one that I'm always using, this expected value, stays in the same spot. It's super handy. So I can say that my variance of x, which is equal to sigma squared, is going to just be equal to the sum of this column. And it has a huge number here. So sometimes we use scientific notation, but if you kind of stretch it out, it will go into numbers. You can also force it into number format if we play around with the numbers here. And so we can also say that this is the standard deviation of x, which is equal to just sigma, which is going to be equal to the square root. And in Excel, we can do that by just typing sqrt of the variance, and we get that this is our standard deviation. And I'm not going to do it for the other side, but it follows the exact same equations, and that is how we can calculate out both our variance and our standard deviations with our probability tables. And this is for our kind of general examples that we had. Okay, well, that's how we do it. That's how we answered that first one on the guide. Good luck on doing your general probabilities on your own.